Have you ever had a conversation with an artificial intelligence that felt so real you forgot you were talking to a machine? As a data science director at a Fortune 4 company and a Harvard physics PhD, I'm constantly amazed by the capabilities of modern AI. In this channel, there will be weekly updates on interesting AI topics, so if you are new here, please consider subscribing. Today, we're going to explore one of the most advanced AI systems in existence, ChatGPT. In this video, we'll take a deep dive into how ChatGPT works and how it's able to generate such human-like responses. But before we get started, let me clarify one thing. Large language models like ChatGPT are not sentient beings. They are simply highly advanced machines that are calculating the probability of the next word in a given sentence. At the end of this video, I will point out jobs that cannot be easily replaced by AI. So make sure to stay tuned to the end to find out which jobs are AI-proof. So how does ChatGPT work? Let's find out. ChatGPT is a large-scale generative language model developed by OpenAI, designed to generate human-like text by predicting the next word in a sentence. It's a cutting-edge artificial intelligence system that has garnered a lot of attention in the past few years due to its impressive capabilities. With over 175 billion parameters, it's currently the largest language model in existence. Now that we've covered the basics of what ChatGPT is and how it works, let's take a step back and talk about this technology that makes it all possible: neural networks. At their core, neural networks are a type of machine learning algorithm that are modeled after the structure and function of the human brain. They consist of layers of interconnected nodes, or neurons, that are designed to process and interpret complex patterns in data. So how do neural networks actually work? Let's take the example of image recognition. When you feed an image into a neural network, the first layer of neurons, known as the input layer, receives the raw pixel data from the image. From there, the data flows through a series of hidden layers, where the neurons perform mathematical operations on the data to extract features and patterns that are relevant to the task at hand. These patterns are then combined and analyzed in the final layer, known as the output layer, where the network makes its prediction. But how does the network learn to recognize these patterns in the first place? That's where the concept of weights and activation functions come in. Each connection between neurons in the network is assigned a weight, which determines the strength of the connection. During the training process, the network adjusts these weights based on the patterns in the data in order to optimize its predictions. At the same time, each neuron in the network also applies an activation function to its input, which determines whether the neuron should fire or activate based on the strength of the input. This process of activation and weight adjustment is repeated over and over again during training until the network is able to accurately recognize patterns in the data. ChatGPT is a large language model that is trained in 3 stages: generative pre-training, supervised fine-tuning, and reinforcement learning. The first stage of generative pre-training is a transformer-based neural network, which is capable of processing and understanding complex language patterns. But how does it learn to do this? To train ChatGPT, the OpenAI team fed it a massive amount of text data from the internet, totaling over 45 terabytes of information. This data includes everything from news articles and scientific papers to social media posts and online forums. The goal of this stage is to teach the model to understand the nuances and complexities of human language, so that it can learn to predict the probability distribution over the next word or token in a given sequence of text. This is achieved through a process called unsupervised learning, where the model is trained to predict the next word in a sentence or sequence of text based solely on the preceding context. By training on this task, the model learns to capture the underlying structure and patterns of language and can generate coherent and grammatically correct sentences. For example, given the sequence of words "the cat is," the model might predict the next word to be sleeping, playing, hungry, or any other word that could reasonably follow "the cat is," based on the vast corpus of text it has been trained on. Once the model has been trained in this way, it can generate text by sampling from the probability distribution over the next word in the sequence based on the preceding context. By repeating this process multiple times, the model can generate entire sentences, paragraphs, or even longer passages of text. However, there's a misalignment between the task implicit in the language modeling objective and the downstream task that the model developers or end users want the model to perform. As an example, if you ask what is the largest country in Africa, there's a chance that ChatGPT will answer what is the largest country in South America, what is the smallest country in Asia, because its training data may include a large number of lists of questions like this. This is obviously not what we want. So there's a need to teach ChatGPT that when asked what is the largest country in Africa, it should answer Algeria, even if the probability distribution for Algeria is low. To address this, we go to the second stage of training, the supervised fine-tuning stage. Fine-tunes the model to mimic ideal chatbot behavior demonstrated by humans. Human contractors conduct conversations where they play both sides, both the human user and the ideal chatbot. These conversations are aggregated into a dataset where each training example consists of a particular conversation history paired with the next response of the human acting as the chatbot. The objective is to maximize the probability the model assigns to the sequence of tokens in the corresponding response. This can be viewed as a typical imitation learning setup, specifically behavior cloning, where the model attempts to mimic an ideal behavior demonstrated by humans. The model's training doesn't end there. We go to the last stage, which is a reinforcement learning stage. It further trains the model with human feedback, where human preferences over alternative model outputs will be used to define reward function or additional training with reinforcement learning. Why is this necessary? The OpenAI team can use a negative reward to prevent ChatGPT from generating offensive material and positive reward for good answers to questions. The goal is to make sure any offensive material will have zero probability distribution. The model learns to optimize its output to maximize the reward function defined by the human feedback. The weights of the model are fine-tuned from the results of the previous stage in each of these steps. There are some jobs that may be at risk of being taken over by ChatGPT and other AI technologies. For example, customer service jobs that involve answering simple queries or complaints could be automated, as could some jobs in the field of translation or content creation. But not all jobs are at risk. Jobs that involve complex problem-solving and decision-making in unpredictable situations such as emergency responders, social workers, and therapists. These jobs require a high level of empathy, intuition, and adaptability, as well as the ability to work with incomplete or ambiguous information. While AI can assist in some aspects of these jobs, such as analyzing data or providing recommendations, it is not yet capable of replacing the human element in these important roles. There are also certain jobs that involve working with unique or rare data, which makes them unlikely to be taken over by AI. This is because machine learning models, like large language models, require massive amounts of data to learn and make accurate predictions. For example, jobs that involve researching rare diseases, discovering new species, or studying ancient artifacts require a deep understanding of the subject matter, which can't be easily replicated by an AI model. Finally, there are jobs that require a high level of physical dexterity and manual skills, such as construction workers, mechanics, and chefs. While AI can assist in some aspects of these jobs, such as providing recommendations or analyzing data, it is not yet capable of replicating the fine motor skills and tactile sensations required for these tasks. But let's not forget the importance of ChatGPT in the field of artificial intelligence. Its ability to generate human-like language and assist in complex problem solving has the potential to transform the way we work and communicate with each other. It's an exciting time to be exploring this technology and its possibilities. So I encourage you all to continue exploring the topic further and learn more about ChatGPT and its impact on the job market. If you found this video helpful, consider subscribing to our channel, give us a like, and share it with your friends. Thank you for watching.